Welcome to the systemic history of Operation Overlord. Today, we aren't looking at D-Day as a battle. We're looking at it as the greatest engineering startup in the history of the 20th century, and how math, concrete, and steel pipes defeated Hitler's Atlantic Wall. Imagine you are a logistics officer in 1943. You're handed a piece of paper with a single requirement. By the end of D-Day plus 30, you need to have landed 1.3 million men on a beach. But here's the catch. Those men are useless the moment they land. To keep them fighting, you need to deliver 12,000 tons of ammunition, food, and fuel every single day. That's roughly the weight of the Eiffel Tower, shipped across the most dangerous stretch of water in the world and dropped onto sand. No docks, no cranes, no warehouses. Just 50 miles of French coastline, defended by the most sophisticated concrete fortification system in human history. Military experts at the time said it was a suicide mission, not because of the German MG-42s, though they were deadly, but because of the math. History books focus on the heroism of the paratroopers and the blood on Omaha Beach. But the real story of why the Allies won isn't just about bravery. It's about a group of engineers who looked at the English Channel and decided to build a city, a gas station, and a harbor, and then float them across the sea. In 1944, the German High Command wasn't stupid. Rommel knew that an army of 1 million men needs a deep water port. Without a port like Cherbourg or Le Havre, the Allies couldn't land heavy tanks, trucks, or enough fuel to move an inch inland. This created the invasion paradox. 1. You need a port to win. 2. But the ports are the most heavily defended places on Earth. 3. If you attack a port directly, the Germans will blow up the docks before you take them, making the port useless. The Germans bet the entire war on this logic. They figured, if they don't have a port, they can't stay. If they can't stay, they die on the beach. But what if you didn't take a port? What if you brought one with you? This sounds like a steampunk fever dream, but it was the systemic solution to the Nazi Atlantic Wall. The project was codenamed Mulberry. But before we get to the giant concrete monsters, we have to talk about the most boring and most vital substance in the world: gasoline. Think about a Tiger tank. It's a beast, but without fuel, it's just a 54-ton paperweight. The Allied Project Overlord had thousands of vehicles. If they stopped moving for even 24 hours because they ran out of gas, the German counterattack would push them back into the sea. The traditional way to move fuel is tankers, but tankers are massive, slow targets for U-boats, and they need, you guessed it, a port. So the engineers asked a question that changed the war. Can we build a straw long enough to reach from England to France? This is where the story gets weird. The project was called PLUTO, Pipelines Under the Ocean. The challenge was insane. You need to lay a pipeline across 70 miles of the English Channel. It has to withstand the massive pressure of the ocean floor. It has to be flexible enough to be laid from a moving ship. And it has to be invisible to German reconnaissance. The engineers didn't look at existing oil pipes. Those were too rigid. Instead, they looked at undersea telegraph cables. They stripped out the copper wire and replaced it with a hollow lead core. Then they wrapped that core in layers of steel tape, jute, and galvanized wire. It was essentially a high-pressure armored hose. But how do you lay 70 miles of steel pipe in the middle of a war zone? They built the conundrum. Imagine a giant floating bobbin, 50 feet in diameter, with miles of pipe wrapped around it. These massive drums were towed by tugboats, unspooling the straw across the seabed as they moved. By the time the system was fully operational, it was pumping over 1 million gallons of fuel a day directly from the British mainland to the front lines. The Germans were looking for tankers. They never realized the Allies were literally drinking through the ocean floor. But fuel is only half the battle. You still have the weight problem. Tanks, crates of ammunition, millions of K-rations. You can't pump a Sherman tank through a pipe. Which brings us back to the Mulberry Harbors. And this is where the scale of this project goes from impressive to absolute madness. When Winston Churchill sent a memo about the artificial harbors, he famously wrote, They must float up and down with the tide. The anchor problem must be mastered. Let me have the best solution. The solution was 2 artificial harbors, each the size of the port of Dover. One for the Americans, Mulberry A, and one for the British, Mulberry B. But they weren't just docks. They were a massive modular system consisting of 3 distinct layers of engineering. Layer 1, the gooseberries. The engineers took 60 old, obsolete ships, merchant vessels, and even an old battleship, and intentionally sailed them into the shallow waters off Normandy. Then, they blew holes in the hulls and sank them. These block ships created a 5-mile breakwater, a wall of steel to calm the violent channel waves. Layer 2, the phoenixes. Behind the ships, they needed something more permanent. They built 146 massive hollow concrete blocks called phoenixes. These weren't small. The largest ones were 5 stories tall and weighed 6,000 tons. Imagine trying to tow a 5-story building across the ocean while someone is shooting at you. That's what the Allied tugboat crews did. Once in position, they opened the valves, flooded the blocks, and parked them on the sea floor to create a massive outer wall. Layer 3, the whales. This was the most brilliant part. You have the breakwater, but how do you get the trucks from the ships to the beach? You need piers. But the tide in Normandy is brutal. It rises and falls up to 24 feet. A fixed pier would be underwater half the time and too high the other half. So they built whales, floating roadways made of steel spans that rested on beetles, concrete pontoons. These roadways literally breathed with the ocean, rising and falling with the tide, allowing a constant stream of traffic to drive from the ships directly onto the sand. In the first 100 days after D-Day, these fake ports landed over 2 million men and 500,000 vehicles. But just as the system was reaching its peak, nature decided to remind the engineers who was really in charge.
This is the moment the project almost failed. On June 19th, 2 weeks after the invasion, the worst storm in 40 years hit the English Channel. It wasn't a skirmish, it was a 3-day hurricane. The American harbor, Mulberry A at Omaha Beach, was in the worst spot. The waves were so violent, they actually picked up the 6,000-ton concrete phoenixes and smashed them into each other like they were made of glass. The floating whale roadways were twisted into scrap metal. By the time the storm cleared, Mulberry A was a total loss. The American commanders were devastated. Logistics was collapsing. The supply line was severed. They considered the project a failure. They went back to beaching ships, literally driving transport ships onto the sand at high tide, unloading them frantically and waiting for the next tide to float them back off. But here's the unexpected insight. The Americans realized that the remnants of the destroyed harbor, the sunken ships and the broken concrete, still provided enough of a breakwater to allow their primitive beaching methods to work. Meanwhile, the British Mulberry Bee survived. Why? Because the British had been slightly more obsessed with the what and how of the seabed. They had anchored their phoenixes into a more stable clay bottom, whereas the Americans had placed theirs on shifting sand. The artificial harbor project proved 2 things simultaneously. First, engineering can conquer geography. Second, even when engineering fails, the system of logistics is what wins wars. The Americans were landing more supplies on a broken harbor than they ever did when it was functioning perfectly, simply because they were forced to innovate on the fly. Most war movies end with a flag being raised on a hill. But what ensured the success of Operation Overlord is a completely different story. The victory at Normandy wasn't just a triumph of the spirit. It was a triumph of the supply chain. If the PLUTO pipeline hadn't worked, the Allied tanks would have stalled in the hedgerows of France. If the Mulberry Harbors hadn't been built, the initial beachhead would have been starved out within a week. We often think of history as a series of great men making great speeches, but history is actually a series of massive problems being solved by people who are good at math, people who know how to pour concrete under pressure, and people who can figure out how to lay a pipe across a sea. The D-Day project was the blueprint for the modern world. The modular construction we use in offshore oil rigs, the way we manage global shipping ports today, it all traces its DNA back to that summer in 1944.
When you look at a photo of the D-Day landings, don't just look at the soldiers in the Higgins boats. Look past them. Look at the horizon. Look at the miles of steel roads, the concrete monsters, and the invisible lines of fuel pulsing beneath the waves. That is where the war was actually won. Not with the bullet, but with the project.